All right, so in this video, we're going to cover the first part of these two examples, which is an introduction to measurement and exponential or scientific notation. Here's the goals for this section. We want to be able to write in exponential notation a number given in ordinary decimal form, or do the opposite, write in ordinary decimal form, a number expressed originally in exponential notation. And then we want to get familiar with using our calculator for adding, subtracting, and multiplying numbers expressed in scientific notation or exponential notation. So the question is, why do we want to do this? Why do we want to use exponential notation? Well, before we talk about that, a question would be, how tall are you, right? So this is our intro to measurement. So this is the world's tallest man with the world's shortest man, and I forget how tall this guy is. Quite taller than me. I'm 6'3", so it's quite tall. I think maybe even over 8 feet. And if I asked you, how tall is this guy? And you said to me, well, professor, he's 5 shoelaces tall. Okay, that doesn't really help, right? Because 5 shoelaces isn't an agreed upon standard. So in order to describe things and compare things, especially in science, we need a system that's agreed upon. And that's what the metric system would be. All right, so the metric system or the SI system, you kind of will see them both interchangeably, uses these base units to explain, all right, different measurements. So you have mass, length, temperature. They're expressed in kilogram, meter, Kelvin, and second. And some of these might be different for how in the US we would express mass maybe in some other unit like a pound, or length in terms of feet, right? Or miles, right? So this is going to be a little bit different maybe for some of you, but it's really important, again, to have this agreed upon standard, to understand it, and we'll get plenty of practice doing that, and then to use it to get at other units or derived units that we'll talk about later in the semester. So again, we have these units that are agreed upon, but that doesn't answer the question, well, why do we need exponential or scientific notation? Well, the reason we need it is because scientists generally work with really, really large or really, really small numbers. For example, here's a helium atom, and let's say I wanted to write out the mass of a helium atom. So let me just count here. So I think this is right. I'm going to probably write it wrong, and you can correct me later. So if I was going to write it out just normally, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. All right, this is the mass of a helium atom. It's incredibly tiny, and I maybe added a 0. I may have left some zeros off. I tried to count on my notes here, but that's really the point, is that it's inconvenient to write a number this big in this way. You're likely to get it wrong, like I may have gotten it wrong just now, okay? And it just takes up a lot of space, and it takes up a lot of time if you're writing calculations out this way. So again, now for another example, if we wanted to know how many atoms of helium are in a balloon, a helium balloon, well, that number is probably incredibly large, right? So because we're dealing with such large numbers and such small numbers, we need a better way to simplify this. Okay, so we're going to simplify with oops, that's supposed to be now, exponential notation. All right, we want to be able to describe, again, these really big and really small numbers in ways that are more manageable for us. Okay, so how do we express a number then in standard exponential notation or in scientific notation? So a number can be written in standard exponential notation, or again, scientific notation, as follows, okay? So I've kind of broken it up into this form. So A here, I'm going to break down each part, okay? And it'll make more sense when we do examples, but this is just kind of showing you everything right now. So A, okay, is a number. Oh, excuse me. I was doing so well, and now it's acting up again. So a number equal to or greater equal to or greater than 1, okay, but less than 10, okay? So A can be a number, all right, greater than 1 or equal to 1, but it has to be less than 10, okay? So in other words, if I could write here in a different color, all right, so this is okay, right? 1, oh, that's terrible to see. Hold on. I'll write it in green. So in other words, this is okay, okay, if that's the decimal spot there, but this is not okay, okay. So 10 is not okay for this value of A. All right, so I'm just going to erase these guys. You can put that down in your notes, but just to give myself a little bit of extra room, I'm going to erase them. Now, B, C, D, these are the numbers that are after the decimal place, okay? And you can have any number of digits after the decimal place here, all right? So all right, so it can just kind of go on quite a bit. And again, we're going to do examples to show this. So E here, all right? So E, excuse me, so this is an exponent, all right? So the power, so 10 to this power is an integer, excuse me. I said that funny. Sure, okay, so it's a whole number. This is what that means. So it's a whole number and can be positive or all right, so let me just give you a few examples here. Before I do that, let me just summarize everything that's here for us. So A is a number that is equal to or greater than 1, but less than 10. All right, then there's a decimal there, decimal point. And then the numbers after that decimal point can be, you can have any numbers, any amount of digits after that decimal place, okay? And then E here, the exponent, is an integer that can be positive or negative, or a whole number that could be positive or negative. So here's some examples of what E could be. So let's say I had 10, I'll just write a few examples here, all right? So if I had 10 to 2, that would be acceptable. 10 to minus 2, this would be acceptable, okay? 10 to 3, that would also be acceptable. And what these represent, okay, is the following. So this would be 100, okay? This would be 1,000. And I left this guy last because he's going to be a decimal. 1, okay? So they're multiples of 10 is what that is, all right? So what the 10 to the exponent means, again, is just different multiples of 10. So 10 raised to the power of 2 is 100. 10 raised to the power of -2 is a hundredth, okay? 10 to the power of 3 is 1,000. And there's a chart that should be in your book that goes through each one of these. I won't write them all out. But if you're confused, that's all right. Just hang in there, all right? We're going to do plenty of examples together, and this is going to become clear. But this is kind of something for you to refer back to as a reference. Again, just me going over the details of all of this. All right. But that's the idea. Just to summarize again, A is a number equal to or greater than 1, but less than 10. Then there's a decimal point, and you can have any number of digits after the decimal place. All right, and then 10 raised to some exponent. That exponent has to be a whole number that can either be positive or negative, and it represents different multiples of 10. All right, so let's do an example. Like I said, let's do some examples so this makes more sense. It's not very hard. How do we convert between a number and standard exponential notation? Or excuse me, how do we convert, between a number to standard exponential notation? I'm not sure if that's what I said. It seemed like it came out wrong, so probably not. You can correct me later. So here's our example. Convert 724,000, the number, to standard exponential notation. Well, how do we do that? Well, there's a few ways. Maybe you've already done it in your head, and if you have, that's great. You might even have a calculator that can convert between an exponential and a number to standard exponential notation, to a number that's not. But even if you do, hold off on using the calculator. Let's try to do this together so we understand what the calculator is doing. So here's our steps. So step 1, I'm going to just rewrite the number. And what I want you to do with me is imagine a decimal place. Oh, that's bad. Right there. Imagine a decimal point, excuse me, not a decimal place. Imagine a decimal point right there. All right? And remember our rules. You can go back to the other slide if you want, or rewind a little bit and rewatch our rules. That A, if I write this down again, so we have A, B, C, D times 10 to the E. This is the format that I want to get this number in. And remember, A can be greater than or equal to 1, but no more than 10. So in other words, I have to move this decimal point over until there's only one number in the A spot. So let's do that. If that didn't make sense, let's do this. So 1, 2, 3, 4, 5. Well, I think I counted wrong. 1, 2, 3, 4, 5. No, I counted right. Okay. So I moved over 5 places, and I put the decimal point here now. Okay? So we counted that. Move the decimal point over until there is only one number in front of it. Okay, that's step 1. So move decimal point over until there is only one number in front of it. All right? So step 3. Why did I say step 3? That doesn't make any sense. There's only one step on there. This is step 2. Okay, step 2. The number of decimal places that you moved is the exponent E. All right, so 7.2400 times 10. We moved over 1, 2, 3, 4, 5 places, okay? So that means this exponent is going to be a 5, okay? So the decimal point moved 5 places to the left. And I'll say this now, and I'll probably say it again. Every time you move the decimal point to the left, like I just did, E is going to be a positive number. Okay, every time you move it to the right, e is going to be a negative number. Okay, so I'll explain that as we do more examples. So, and this is a multiple of 10. It's 100,000 if you look on the chart. Okay, and that makes sense because we have 724,000. So it should be a fairly large number here represented by the exponent. So now the last step is get rid of those zeros. We don't need them. Okay, so I'll write that here. I'm going to just change my color. So get rid of zeros at the end here. We don't need them. Chop them off. That's the last step. And voila, this is our number represented in exponential notation. 4 times 10 to the 5th. All right. So there you go. And if you left the zeros on there for now, it's not, so big a deal as far as just getting practice moving the decimal point. We're going to talk more about why we would get rid of the zeros when we talk about significant figures, excuse me. So we're just going to get them off for now. We don't need them. All right, so that's an example of how we're going to convert a number into standard exponential notation. So here's another example, okay? And then we'll end this video, and then in the next video, we'll do a few more examples together. So as that's coming out. All right, so convert this number, 0.000427, to standard exponential notation. All right, so let's write down my steps again. So step 1, I'm going to rewrite the number, mainly because I need more room to work. Okay, there's my decimal point. What am I going to do? Well, what I'm going to do is I'm going to move the decimal point again until there's only one number in front of it that is either greater than or equal to 1, but less than 10. Because I want to get in this format, okay? So let's move it together. So this time I'm going to move the opposite direction. I'm going to go over 1, 2, 3, 4 places. All right, the decimal point's going to go there. So now in the next step, this is going to look something like this. I'm going to leave the, you know what? No, I'm not. I'm not going to leave the zeros on. So it's going to look like this, 4.27, okay, times 10. And now how many places did I move over? 1, 2, 3, 4. So this is a 4. And I moved over to the right. So because I moved over to the right, this is going to be negative. All right. So again, in the first example, you can go back, rewatch it. We moved left. So the integer is positive or a bigger number. I moved to the right here, and it is a smaller number. And one last thing you could do to check if what I was saying there doesn't make sense or if it's a little confusing, maybe what I'm about to say is more confusing, but I think it's how your textbook describes it, is this number here, 4.27, the number we end up with, is bigger, okay, is greater than the number we started with, which is 0.000427, all right? So anytime that happens, the number that you ended up with is greater than the number you started with, the exponent e is always negative. All right, so the opposite is true if the number that you end up with is smaller than the number you started with. In that case, the exponent will always be positive, okay? And you can go back to the other example and see how that is true. All right, so that's just another way for it to be explained. And this is just 2 examples. I'm going to stop the video here. I think it's getting a little long. And in the next video, we're just going to do several examples together of just practicing this, because it might not make any sense to you now, but I think it will after we do several practice problems. So see you in the next video.